Jacob Mather, and this is Testing Browser JavaScript Completely. A little bit about me. I'm a senior software engineer at Kixeye. They're a game company in San Francisco. I'm also a co-organizer of the San Francisco PHP user group, and I call myself a community evangelist. It's very important to me to encourage people to come out to community events like this conference, because that's where you make the connections to meet other people, to understand the people behind the tools that make the tools that you use every day. And so when you run into trouble with those tools, and you already know the person, you just ping them on Twitter and say, hey, what's wrong with your broken stuff? And they'll say, hey, send me a PR. And everybody's friendly because you know each other. It's hard to do that when you haven't met them in person. If you like to talk, I blog at jmather.com. I tweet on Twitter at thejmather. So, story time. About a year and a half ago, somewhere around there, my team and I started building a new JavaScript front end for our product. And we had one developer who specialized in JavaScript on the team. And the rest of us were used to writing PHP. So we had a lot of things to figure out. And Mastery is very test-oriented. We like to know what's going on with our code. We like to know that our code is working like it's supposed to. So figuring out the testing situation for JavaScript was pretty high importance for us. Now, because I'm generally like the cobble things together guy and make it work, I got set on running JavaScript unit tests work and making it work nicely for us. So I went to Google and I said, how do you set up JavaScript testing, right? Unit testing in JavaScript. And I get back like 50 different answers. And that's usually all good. You want more information. So I started to piece together the information, and JavaScript testing, at least at that point, was kind of a smorgasbord approach. Because I'm used to the environment like PHP or Java, where you have PHP unit or JUnit, and they're full solutions. You install PHP unit, and you have regular unit tests. You have code coverage information coming through. You have the entirety of this system, right? So you write your test and you just run PHP unit and it does everything for you. It takes care of it. It has mocking built in case you want to mock objects for testing dependencies. Everything just nice. And I didn't realize how nice it was until I tried to test in JavaScript. Because in JavaScript, you start by picking a test runner. And that's the system that merely finds the files that you want to run for the testing environment. And sometimes it'll also include a little bit of the code layer for executing the tests. And then after you have the test runner, you need the assertion framework. Because they couldn't just tie them together. Everybody has their own opinions, especially in JavaScript land. So you have to pick an assertion framework. There's should, there's expect, there's Jasmine, there's a number of other ones, especially now. And then after that, once you get a little bit deeper in, you realize you need mock objects. And lo and behold, you have to go and pick a mock framework as well. And so it's a little bit more piecemeal, and it's a little bit of work to try and figure out all the pieces that you put together. And so I finally found everything, got everything like cobbled together and running. And so we had the ability to just type, grunt test in our command line, and it would execute all of our tests as we expected. Cool. We get a little further along in the project, and we start building objects that attach to the HTML DOM. And that's when I find out that when you Google for JavaScript testing, what they're talking about is Node. They are not talking about JavaScript that runs in the browser. JavaScript that runs in the browser needs other tools on top of it. Either you need to have a layer that pretends to be the DOM, so everything can work kind of correctly, or you need to actually have a browser to run in. Now, the trick with this back then is because we had this working setup, and I realized it was actually like executing inside of Node instead of executing inside a real browser environment. I tried to do the side-loading DOM structures and everything, and it just wouldn't work correctly for me. which meant that it was time to throw out all of the work that I had done thus far and start over from scratch. Because what I really needed is I needed the unit tests to run inside of a browser so that I knew that the unit test would actually run in a browser. And I had all of the browser elements like on-load events and just the actual DOM to work with, and could expect it to work regularly because we were building like jQuery plugins and stuff that we wanted to test and attach DOM elements and inspect their states and things. So went back to starting and dug into the tools and found this thing called Grunt Phantom.js or Mocha Phantom.js, something like that. And for whatever reason, it just wouldn't work correctly. Like, it kind of got started going, and then it just fell over. We found another package called, I'll show you later, actually. We get into the code, and I'll show you the specific packages. But I found another package that tied everything together and actually worked correctly. And so we could actually run all of our unit tests inside Phantom.js, which is a headless browser. But we could run them from the command line so that we didn't have to keep a browser open. We didn't have to do any of the tricks. We could just execute grunt test. It would start up this headless browser, load our testing suites into it, execute them, and report the results. And it would also export it to like JUnit format so that we could hook it into Jenkins and everything like that. So, cool. We have unit tests. We can actually tell if our code is doing the things we want it to do. There's one other side to testing that people forget about, though, and that's code coverage. And when I had the original setup, I got code coverage working with Istanbul. And if you haven't used Istanbul for testing JavaScript code coverage, I highly encourage you to go look at it. It leaves every other code coverage tool that I've seen in the dust. Most code coverage tools for JavaScript will just tell you line coverage. Istanbul will tell you line, branch, and file, and like it covers all of the things that it can. And it just gives you a lot more resolution. And I'll show you an actual example of the output of the code coverage for it. And so I was very interested in getting Istanbul hooked back up to this new system. However, Istanbul was used to being run in Node. And the way it sets itself up is it instruments your code, and then in the global namespace variables, you have this variable that contains all of your coverage data that it then writes back to a file. Well, guess what happens when your code is running inside a headless browser? It can't write to your file system. Fortunately, one of my coworkers figured out how to write a hook into the server layer that we ran in Grunt for the actual test execution. And so we were able to write a after test hook, which took the coverage data and sent it back to Grunt, which would then write it to a file, so that Istanbul could then do the rest of its work for the code coverage. That, all said and done, was a process of about 3 months to get set up and working properly, learning all the dead ends, learning all the ways we went wrong. It was a huge debacle, really. And so what I did is I took all of the patterns that we figured out and I embedded them into a source code repository that's up on GitHub. And I also apparently closed my editor. Oh, it's there. Okay. So, real quick, let's look at the pieces. We use Grunt for our command line interface. There's lots of different options. Grunt was the tool that we used, that we knew as a team, that our one JavaScript guy knew. We have additional couple pieces. Connect is the tooling that allows us to start servers in the background so that we can serve up our JavaScript to the headless browser. Shell and open are for doing just some nice tricks within the Grunt commands for making things look a little bit nicer. Of course, we have Istanbul. We have Grunt, Mocha, Phantom.js, and we have Bower for loading our actual JavaScript testing dependencies. Now, theoretically, I could have just pulled in, Mocha and Chai and everything from NPM. But since I'm testing browser code, it made sense to me that I would use the browser dependency tool to pull in those requirements. And so it felt cleaner that way. And so if we look over at our Bower file, we bring in jQuery and require.js. That's like the general go-to things you want to use as far as, maybe not jQuery, but require.js is, as far as I understand, still generally the gold standard for dependency loading in JavaScript. And then for testing, we have Mocha, which is our test runner. We have Chai, which is our assertion framework. And we have Sign-On, which is our mocking framework. And they have an additional plugin that ties Sign-On to Chai a little bit more nicely. So I have a little bit of test data set up. Here's an example class written, ready for require.js to work. We use useStrict because that tells JavaScript to just be a little bit more grumpy with us and help us not use some bad patterns. We declare our object. We add a test method to it. And then we export it so that this is how the require.js stuff works, is you define what you're actually exporting. Now, if we look over at our tests, you'll see the same sort of basic setup for the test. We encapsulate it all. We have useStrict for making it more grumpy with us. And then we pull in our class, just require lib test object. We instantiate it. The Mocha is kind of they say it's BDD. It doesn't really speak like BDD to me. I think other people put more meaning into BDD than I do. I think I just see it differently. But so you set it up, you say, describe what you're testing, and then describe more specific tiers, and we'll show you how this actually all pans out at the end. And then for each specific test case, you say it, and then you describe what this condition is that you're testing. And then you provide a function to execute that tests that case. So if we want to actually run this real quick, you'll see that everything maps over. The described show up as the title lines, and then the it shows up as the actual thing that got tested. So there's a couple tricks and things that we've built into this. Because, so say you've got this and you have one test that's going kind of funky, and you want to figure out what's going on with it. And you want to see you want to be able to inspect the state of what's happening while you run that test. Well, I created test browser so that it'll come right up and show you the actual browser version of the way the tests execute. That lets you dig in and find more specific information about failures. We also have Grunt coverage. This goes through, executes the test, and brings up our test coverage. Let's make this a bit larger so it's easier to see. And so we can go into scripts lib, and we'll see we have test object. And we'll see that we have 100% coverage of statements, branches, functions, and lines. And you can actually see which lines it's tested, and it'll show you which lines it hasn't or which branches it hasn't. And so now if we go in here and we say, we change our test. Let's add a parameter and say if thing return broken. Now we have a little bit different setup. Let's go over here, test our coverage. Our coverage changed. We're missing a branch. And this is why I think the code coverage that Istanbul provides is important. Because if you just tested lines, granted, you would see that line covered, that line isn't covered, but it wouldn't necessarily tell you why the line wasn't covered. And having the more detail gives you more specifics of what you're actually looking to accomplish. Because you can trick line coverage. If what you're going for is line coverage, you can simply do return, let's see, thing test case. We've now collapsed it down to a single line. So if we run coverage, oh, and I broke it because I changed the response. What was it supposed to be? Oh, test class. Go back here. Make sure our test passes. We pass. Go back to coverage. Pull this back up. Now see, if we didn't have conditional coverage, if we didn't know if we tested all of our branches, our tool would tell us our code was fine. Our tool would tell us we had 100% code coverage because we had all of our lines tested at least once. But we tricked it because we put two conditions in one line. And so the additional code coverage we get with Istanbul is actually like really important, I feel. And that's why I spent so much time making sure that Istanbul would actually work. Real quick, let's dig in a little bit to demystify this repo, because I'd hate for you guys to leave here and check it out and start using it and run into trouble and not like understand how it's working. So let's start at the Grunt file. The Grunt file is like the definition of all the different tasks we want to be able to do. It's a little strange in its config, and there's some stuff that's kind of a little bit voodoo-y because I really didn't know what I was doing when I built it at the time. But it, in general, pretty much tends to work, and this is pretty clear what's going on. So in this section for shell, these are all just commands that you can run directly. You're just like mapping a grunt command to a shell command. And so we set up a easy command for running our code coverage, and an easy command for running Bower. Just makes it simpler. This is the configuration for Phantom.js. When we're running it in the client, we want to pull up index.html and use the spec reporter because it looks pretty. When we're using it for continuous integration, we want it to output to a log file. We use that same main file that we go to start it, and we use xunit for the reporter so that we can have a report that the continuous integration system can consume easily. When we're doing code coverage, we actually use a separately defined port and process because we have to instrument the JavaScript code before we can run the coverage. And so it's actually a different directory that it's reading from. I built a simple test for open because the automatically kicking open the code coverage and kicking open the browser test page we use with open. So that was just my making sure it works. Connect is the library that enables you to build like a server within your Node.js instance so that we can serve the JavaScript to our headless browser. Now, we have a couple different kinds. We have the keep alive version, which we use for the browser pop-up tests because we need the server to stay running while we have the browser open. Because you might hit refresh after you change some code. You might want to play with it a little bit. And so we didn't want to just spin the server up, send you the report, and stop. We wanted to make it usable. We have a separate one defined for running tests. And this one is built not to stay alive and not to run debug and just to run cleanly. And this is what you use when it's executing in the command line. Now see, if I run grunt test, you see you just get the report, right? But if I run grunt test browser, it brings us over here. We see our test results over here. Back here, you see a debug log of all the files requested. This can be very, very, very helpful when, for whatever reason, your test is deciding not to work, but everything else looks fine. Because this will point out 404 very nicely for you. If you have a wrong file name somewhere, especially caps capitals can mess things up if you go back and forth between different environments that have different requirements for file names. If somebody can come up with a way to easily make this detect when you have a casing error that you're going to run into, that would be awesome. Like that's the last little piece of niceness that I could think of for this, is if it could automatically detect that when you push this to an environment that cares about file name case, you're going to have trouble. That would be cool. Now for coverage. Coverage was an interesting beast, because what we have to do is we have to instrument the JavaScript code that we want to test for coverage. And then we have to set up our server to serve from it. And so now you see right up here, we set up the test serving the same way, but then we set up the software. We serve from a different directory. We serve from coverage, because that's where our Istanbul puts our encoded files for testing coverage. And then we also have this extra chunk of code. And this is the chunk of code that once testing has finished running in the headless browser, it triggers a callback to deliver the code coverage information back to Grunt, so that we are able to write it to a file so that Mocha can process, or that Istanbul can process it when we're done. Now, we ran into some other weirdness, and that's you have to actually pass all the files that you want to test into the browser, because the browser can't talk to your file system. So we have to provide a little bit of added layering on top of that. And so we built a helper method, generate test list, which just digs through the directory and finds all of our test files and pushes them into the browser so that they get loaded correctly. We also created an option flag for file. So let's do real quick. I will copy this and paste it, and we'll do other test object. Yes. And we'll change this to test case. Then we'll come down to our actual tests. Copy, paste. Other test object test. Move this, other test object. And we'll leave this here. And we'll rerun our test. We're going to see a failure because we have our strings wrong. But we have a couple different tests running. So we want to know which one exactly is failing. We figure it out, and we don't want this giant list every time we rerun the tests, because we're just trying to iterate on this one object and get it working correctly. So we just pass file. If we set file and pass the name of the file name that we want to test, it will isolate it and just run that test. I mean, this feels like a duh. This feels like a no-brainer. But I specifically had to build it to do this. It doesn't just do this out of the box. So back to our grunt file. We look down. We have test coverage process. The coverage testing is kind of a really interesting beast because it has a very strange workflow. And to do that, let's just walk through it real quick. So here's the task for test coverage. Test coverage actually calls test coverage init. And if we look at init, it calls our generate test list so that we know the names of all the test files we want. And then it calls this shell coverage thing. Let's look back up at shell. Shell coverage runs this command, and it will show us the output of its command. So let's find this script. So we go to scripts, support, run coverage test. This is a giant mess of stuff. This is the glue that happens to make all the coverage actually work. First, we have to check and see if we're doing it for CI or not, because that depends on what we want for output. We set up some directories and make everything happy. And then here's our initial instrumentation. Now you'll notice there's actually two steps for this. First, we copy our code within the scripts directory of our app, because that is all of our custom code. But we do that with the Istanbul instrument because we want Istanbul to instrument that stuff specifically. And then next, we link our vendor directory over to the covered code section so that we also have access to all the same vendors when we're serving that directory. But we did not want our vendor files to be tested for code coverage. You don't want to do that. Don't test your vendor stuff. If you don't trust it, find another library. Now, this is the part where we actually execute the coverage test. And so now we have a shell script that's been called by Grunt, which is calling Grunt to execute something, which I'm sure I probably could have done cleaner, but so let's find that one. Test coverage process. We call our connect, and we tell Mocha Phantom.js that we want to run coverage. If we run up here, see that's the connect coverage. And then where's our Mocha Phantom.js? Here it is. So here we see we have the options, the URLs. We give it the URL to run and tell it spec reporter because we don't actually care how the report comes back. Because all we want is the actual coverage data from the Istanbul instrumentation. So back to our script. It ran away on me. Here we go. So now, depending on whether or not we're doing it for continuous integration or for ourselves, either we will generate an HTML report and open it in our preferred browser, or we will generate a Kobatura report and stick that where we expect to find all of the logs from the testing framework on the Jenkins front. Let's look back at our grunt file real quick and make sure I've covered everything. The only thing I haven't shown you is the simple grunt Bower command, which just makes running Bower nice and easy. So if you check out this repository, you'll run npm install, you'll run grunt Bower, and then you'll be ready to go. Let's see. Oh yes, there's one last actual set of things we haven't talked about. The HTML files that we point our headless browser to. Those took some trickery as well. Because, believe it or not, that headless browser doesn't come up instantly. It doesn't just work. And the servers don't just come up instantly all the time. And it takes a while to get everything wired and connected. And so what I found I actually had to do is I had to create a loading page for my test framework. Very simple, just a tiny little redirect. That 1 second gives everything enough time to actually get hooked up and warmed up and running correctly, and it gives you consistent results. Without this, I was seeing sometimes we would get random failures, and there's no real expressed reason why it was failing, but it was just failing and not working, and I don't like that. I want things to just work. Right? Because that's how you make people do the right thing. You make it too easy to do the right thing. You make it hard to do the wrong thing. So just build it and patch pieces where you have to. So after a second, it redirects and it loads this file. This is a giant mess. But this is the glue needed to start making things work. We pull in our CSS for the Mocha, just in case we're doing it in the browser and we want to see it look pretty. We pull in Mocha, jQuery, chai, sign-on. Pull in sign-on chai for additional stuff. Pull in require.js for loading our production stuff. The reason I didn't have this just come through the dependency container is because I don't want our dependency container to know about our development dependencies. Require.js was solely for production usage. Anything that was not being delivered to production did not need to go in it. Also, these things I guess that's really, I didn't want them to go in there because it's not a production thing. And it, kind of like a just clarity of responsibility. So down here is a whole bunch of just mess, really. We encapsulate the Mocha running command. We look for phantom.js. And if we're running in phantom.js, then we set up that after Mocha is done running everything, we do our callback if we have the test coverage data. Otherwise, we just run it directly. It's really just, this part should, for the most part, if you start with my repository, probably not have to be touched, unless you want to change the assertion framework you're using or the mock framework you're using. Unless you're changing test system level things, you can probably just let this be. So with the how everything works covered, let's cover some of the common JavaScript testing scenarios. Because now that we have the tools to actually build and properly quantify the tests that we've built, it's time to put some tests in. So let's do a little simple one first. And I'm just actually going to write these inside the test. We'll go and delete our extra objects. Revert our changes here, just so everything runs like we expect it to. And so right here you have the basic one. This is how you test like the simplest piece, right? The simplest thing is to pull in an object, run a method on it, and test the result you got back. Now, what if you need to test a callback, right? JavaScript, it's evented. We try and use callbacks instead of like straight procedural throw. So we'll go describe callback test. Apparently, if I speak while I'm typing, I'll just like not type part of what I'm saying. Okay. So we write our function description here, and we say it calls back correctly, which isn't really a great description of what the test does. Like, I wouldn't recommend, committing a description like that to your repository. You'll probably make your team pretty grumpy, because that's not a description of what it's doing. It's a description of how it's doing it, but not what it's doing. And so we'll make our function simplest case scenario, right? We're just going to have it call the callback with true. Now, how do we test this? Because what we actually want to test is that the callback is called. And so if we just do something like this, and we go back and we run our test. I mean, technically it worked, but that isn't testing what we say we're testing. All that's doing is running the code. There's no assertions. There's no, this actually ran. And so there's actually a couple different ways we can do this. The simplest way is we create a spy. Just like that. And we pass the spy to our test function. And then we say expect spy to be called. Now we have an assertion. Now the test is telling us exactly what we expect the result to be. Come back here. Ooh, I've done something wrong. Is this not a function? Is that what it is? Yep. It's been a while since I've done this. Test expect. Called is apparently a property and not a function. Okay. But we have it set up, and now we know for certain that our code is actually calling it. But in the nature of any true good testing setup, make the passing test fail. We made it pass. Now let's break the code intentionally. our test fails. That means our test is doing its job. Until you do that step, until you take a passing test that's correctly wired and break the object that it's testing, you don't know if your test is actually testing things. You have to trust but verify. So we'll bring it back to a working state. Run our test. Everything's working. All right. So, next thing, what if we are testing events? Describe event tests function. It calls the other call. It calls the other thing. So now we have var a equals function. We don't care what this does. And we'll do var b equals function. We're going to call a. And now, this is all we want to test from here is code execution flow. We want to know, oh, okay, never mind. This is the way we want to do it. I apologize. What we're trying to show is time-lapsed event management, right? So what we have is we'll have our function, which takes a callback. And what this does is it sets a timeout. And we'll execute the callback after 1,000 seconds. And so now, we already know how to test this stuff, right? I'm going to go ahead and grab this and paste that in there. And adapt the code to work like we expect. Hop over here, test it. Why did it fail? We tested the exact same thing, didn't we? Isn't that what we did? No, it's slightly different because you've brought in time to the equation. And when you bring in time, what you actually need to do is get a variable passed in. When you call it, optionally, it passes you in a callback to call when your test is done. So we need that callback. And so instead of using this spy, we're going to use done. Because we've already seen that the test fails without this. So we know that the test is doing what it's supposed to. It's still broken. What did we do? Oh, because we can't test. Because we can't do an expectation on that, because it's not built for it. We just have to call function done. Now, it ran slow, but it passes. Because we passed the context through and told the test how to know when it's actually done running. Otherwise, I think it has probably about a 5 millisecond timer or something where it just counts as a failure unless you are specifically passing around a context to tell it when it's done. So, we've covered basic callbacks. We've covered evented setup where you're going to have time delays. Let's talk about mocks and stubs. So, what we're going to do is we're going to test something that and we'll say, what is this going to do to the object? We want to return 5 plus This will just be a callback that's going to return a number for us. And so now we'll do stub equals returns 3, and then we can do expect thing stub, not strub, expect thing stub to equal, well, 5 plus 3 is 8. Yay! Typing problems. That's why I like live coding. You run into all sorts of fun stuff. So where was that? Expected 5 stub to equal 8. Oh. I must have the terminology wrong. Hey, guess what? We're in an internet-connected world. Sign on. Documentation. We'll pull it up. Test stubs. How do we use them? All sorts of fun stuff. Stub API, sign-in stub, object method. Oh, okay. What does this do? Stub, okay. Return, it's supposed to do exactly this. Hey, you know what we should do? We should test our stub and discover its functionality. Expect stub to equal 3. Let's see if this tells us anything useful. Nope. Oh, okay. So we can't actually look at stub. We're going to call stub. I don't know. I must have something wrong with this. It seems to make much more sense. I did this last night. I literally did this exact same last night, and it worked. I don't know what's going on. So we're going to use a different kind of stub. We're going to cheat. We're going to say our stub is so now, in JavaScript, you can just create the objects that you want to have. You can just build the pieces that you want and throw them in because it's that flexible. You can create object structures on the fly. So don't feel like you have to feel limited to your testing framework too. If it's giving you trouble, if it's not doing what you want it to do it another way. There's, generally about 10 different ways to do something in JavaScript, and usually at least one of them will work at the time you want it to. The last big thing, really, with testing JavaScript is connecting to the browser and faking requests. Sign-in has whole huge sets of libraries. They can override specific classes with the stub system so that you could replace the jQuery Ajax system with a stub that returned the response that you wanted out of it. Or you could replace it with a spy if you were just interested whether or not a call was triggered. You can actually override the XML HTTP request object and intercept calls at that specific level. You can fake responses from the server. The reason I'm telling you this is because this means every single piece of JavaScript code you write can be unit tested. Every piece. Because you can run it in a browser and you can fake responses from the server, which means you run your code in complete isolation. The one other piece you'll want to do is functional tests, but you do that with a different set of tools. If you're interested in functional testing, look at things like Cucumber. They have a specific version of it for JavaScript, and it runs this tool called Selenium, which actually is a programmatic API to control your browser. And when you get even further past that, there's this company called Sauce Labs, which runs server farms of Selenium-enabled browsers, so that any version of any browser on any platform that you want to run, you can. So you taught your system which platforms you want to support, which versions, which details, and use Sauce Labs to go ahead and actually execute your code on a functional test in the browsers you choose to make sure that the behavior is supported across the platforms. The one last piece that I'd like to see set up is, once you have all of that in place, do the same for your unit tests. Run them through Selenium, through a service like Sauce Labs perhaps, so that you can verify that your unit tests pass in every single browser that you say you support. Because it's one thing that the functional tests pass. It's another thing that your unit tests pass. Because the functional tests will only test the cases that you expect users to pass, right? You only outline the cases that you expect your users to flow through in your functional tests, because they take so long to run and they're so expensive. You want to only do the very most important things. Unit tests, on the other hand, those are run quickly. And more of your code base is likely to be unit tested than functional tested. So if you can actually unit test your cases across all the browsers that you want to support, you will know for a fact whether the browsers actually support the systems that you want them to, and whether or not your code is going to run into trouble even before somebody else has a problem. Thank you very much. I have to put in a note for my employer, Kixeye. I work on the team of Battle Pirates. It's a game like StarCraft, but it runs in the browser and it's an MMO. It's real-time strategy, but you play with a whole bunch of people across the world. So lots of fun. We built it in PHP. It's really weird. It's really fun though. So thank you very much. I appreciate you coming out. I know it was really early. I know some of you guys came in a little bit late. I have the entire talk recorded, and I'll have it up later this afternoon. They also have a recording that'll be up at some point if you like to watch me apparently shuffle around and wave my hands. Some people do. They think it's funny. I've been called majestic. Thank you so much. I appreciate your time.